Here's the last video in this day's material, and essentially now we just need to take all of the factoring techniques we've learned. We now have all of them at our disposal and see if we can use that to factor things as fully as possible and then eventually to factor and solve things. So you want to kind of keep that checklist kind of near you, which is make sure it's in standard form. Set it equal to 0, which in this case there's no equal sign for these first few, so those first few steps don't need to be done. Check to see if there's a greatest common factor to take out, and then count the terms and see, does it have 2 terms, does it have 3 terms, does it have 4 terms, because that leads you in the right direction of how to factor. So the first one has no GCF. It has 2 terms, which means it's either a perfect squares difference or a difference or sum of perfect cubes. This is perfect squares. The power of x, or the power of the variable, is really the key. An even power, you're going to look for squares more often than an odd power. So for this one, this is going to factor 9x squared here and here, because that's how we break down the first term, and then plus 4 minus 4, that's how we break down the 16. And then we want to go further and check to see if we can go further. A lot of the ones that say factor fully on Delta Math usually say that because there's more than one technique. This first factor is done. It may be perfect squares, but it's addition, which we can't do. This one needs to go further. So my final answer with this, so the 9x squared plus 4 doesn't change. This one factors 3x plus 2, 3x minus 2. Because it is another perfect square. So this is a double difference of perfect squares. It happens twice. The next one has a GCF. We can take out a 4 because everything's divisible by 4. We can also take out an x squared, which leaves me with x to the 4th minus 5x squared plus 6. Messy. I have 3 terms left. It is a basic FOIL factor, because it has no number in front of the x to the 4th. So this is going to factor, I need 2 numbers that multiply to get 6 and add to get negative 5. That is going to be a minus 2 and a minus 3. And we're actually done at this point. Both of these look potentially like they could be difference of squares. However, the numbers, the 2 and the 3, are not perfect squares, so they are done. Next one, now we're getting into ones where you have equal signs, where you have to get things in standard form, and when you're done factoring, list your solutions. Notice what I'm looking for. I am looking for you to tell me real solutions, list them, and then if there's anything that would create an imaginary solution, please state that as well. You do not have to actually find them. So here we are getting this in standard form. We have 3 terms. We can't take anything out. This is a basic FOIL factor. We need 2 numbers that multiply to get negative 4 and add to get negative 3. That's going to be negative 4 and positive 1. This first factor is a difference of squares, so we can go further and do x plus 2, x minus 2. This one is not factorable we've talked about this in previous videos. Anytime it's x squared plus a number, it will not factor. The other thing we know about this is this creates imaginary solutions. So I'm just going to make a little note of that. My 2 real solutions are plus and minus 2. Next one, we need to subtract 1 to get it in standard form. Nothing can be taken out. There's no GCF. This has 2 terms. We now are looking at something that's a cubed, a third power. So this is a difference of perfect cubes. Again, you might need to reference back to what you wrote down earlier about how you use difference of perfect cubes. You have your A and your B value. A is x and B is 1. It's what was cubed to get x cubed and what was cubed to get 1. So the formula is A minus B, so x minus 1. And then A squared plus a times b plus b squared. This will always create imaginary. This tells me my only real solution is x equals 1. These two, neither of them are standard form, so I'm going to subtract 16 in the first one to get it in standard form. I'm going to subtract both of these two, well, actually subtract the 8x and add the 2x cubed, or 2x squared. That is still not in standard form. Let me put that in a much better order. Sorry about that. Should have done that all at once to save a step. So again, I want it in standard form, so both of these terms need to move over, and I do want the exponents to go in decreasing order. So we'll start with the x to the 4th minus 16. No GCF, but we do have difference of squares. So this is going to be x squared plus 4, x squared minus 4. I can't do anything with the x squared plus 4, but the x squared minus 4 is difference of squares again. You get x plus 2, x minus 2. This is going to be imaginary, and this is going to give me solutions of plus and minus 2. Next one does have a GCF. All of the terms, you can take an x out. Can't take any numbers out, but I can take a variable out. I'm left with x squared plus 2x minus 8. So now I'm looking for a basic FOIL factor, two numbers that multiply to get negative 8 and add to get positive 2. That would be x plus 4 and x minus 2. We actually have three solutions here. We get one here, one here, one here. My solutions are 0, negative 4, and positive 2. This one, to get it started, I'm actually going to have to distribute first. So I'm going to distribute. I get x to the third plus 8x on the left side, and then I get 8x plus 8 on the right side. My 8x's will actually cancel. When I go to subtract, they'll be gone. This 8 needs to come to the other side, so I'm going to get x to the third minus 8 equals 0. That is a difference of cubes. We have two terms. They're both perfect cubes. A is x, b is 2. So my formula is a minus b, so x minus 2. And then x squared plus x times 2, or just 2x, plus 2 squared, which is 4. Again, this gives me imaginary, and this gives me an answer of x equals 2. And then this last one, I want to get everything in standard form. I'm going to put it in the right order first this time. I'm going to subtract the 9x squared, and I'm going to subtract the 84x. GCF, I can take out I wrote this wrong. This should be x cubed. Sorry. I can take out an x. I can also take out a 3. So if I take out a 3x, I'm left with x squared minus 3x. All right, what's 84 divided by 3? 28, I think. 28 times 3 is, 84. So minus 28. Now I can go a little further. I need two numbers that multiply to get negative 28 and add to get negative 3. So that's going to be x 28. So 28 is 7 times 4. So that's going to be x minus 7, x plus 4. I have three solutions here because I have three x values. I have no imaginary, all real solutions, 0, 7, and negative 4. So that's taking you through just some practice ones with these. One thing to notice when you're doing your Delta Math problems, there are a decent amount that have something to take out first. And I think that's the biggest sticking point for students is if they don't take out a GCF at the beginning, they're either going to end up with numbers that are really complicated or impossible. You may have ones that if you don't take out the GCF, you're just completely stuck. So go through that checklist, put things in standard form. Check and see if you can take out a GCF, and then from there, see if you have which of the factoring techniques that you have. And that is finally the end of the 5.3 day one.